So welcome back, guys. Let's continue. So let me create one more scenario over here. The scenario would be something like this. So what I'm doing, let me very quickly create one more new uh, Git repository, right? So initialize workspace 30, 13, I can say, and there's a new, I'm just updating 13 over here. So this will be your new, I can say, the repository. Okay. So what I'm doing very quickly, let's create a file A, or maybe let's say create a multiple file in one go. 4 files we created, but maybe at this point in time, I want to add only one file in my staging area, and whatever file I've added, I would like to commit this thing in my staging area. And guys, interesting thing is when you do dot means all the file that you have in the staging area, they commit. Okay. So mostly, because in the project we have hundreds of thousands of file, whatever file you want to be commit and data you want to be commit. Okay. We normally use dot means put commit all everything. Mostly we use this. But in this context, that will be in your control. If you think you only want to commit A only, put the A in the staging area. That's what I'm talking about. Okay. And I want to show you one more small thing before I run this. I have 4 files. One is there in the staging area. So if I run the git status command, you can see 3 file is untracked, is not there in the staging area. It is only in my working area. 1 file is in my staging area and nothing in the commit area. 1 file is yet waiting for to be committed. So normally guys, status command give you a lot of information here, but if you all want to have a compiled information in the simple compiled way, you can use S. So they can say you very clearly, this question mark say this file is not yet tracked. A means the file is tracked, but it is been added in the staging area, but it's not yet committed. Okay. This S option is something very useful. Now I'll do commit here and say all the file in my staging area, only one file we have in the staging area, I want to commit over here. And as soon as I commit, your commit history created, and you can see on the real time. And if you're in the status, you can see now this 3 file is not yet in the staging area. So anything that is there in the staging area will be committed. One commit we have done. Now, maybe my developer is working on B and we feel now we want to commit the B also. Okay, and this is the first time we are doing, I can say in this way. So we can again go and say add A to my commit area, also B to my staging area. So this 2 file is being part of my staging area. And then I want to do again one more commit. Okay. So again, this will be a quick revision of what we have done in my initial classes, but just trying to show you in another way, other angle with some extra options to you can use respective option as per your requirement, right? So this has also been done. And maybe my developer is working on the next file, new file they added, and I want to also add this file in my staging area, and I would like to add further in my commit. So my status is purely clean, nothing is there, everything is been committed. Okay, you can see the git show command. Okay, they will show you these are the files we committed last. Plus you can see you can use the head option here. Head will tell you the tree. Okay, so guys, 1 minute please. So those who by chance know data structures, so in the data structure we have a tree concept, and every tree has a name, and the name is the one who will tell where the tree is. So you can think guys, head is the one of the way to tell where the tree is. You can see from the graphical also. So head is a one. Say I know my tree. Tree means under me we have one node, then one node means child, subchild, and something like this, right? So head is the one who will tell that I am the tree. So if you see the help of this show command, they say if you can tell me the path or the tree, I can do something for you. Okay, so for example, in the show command, if I had, they will tell something about this tree. For example, in the last class I talk about show files only, these options, right? So I don't want to again repeat, but I just want to tell you, if you tell from this part only, if you can show me the options, I think the option was show files. Show files or show index. You guys remember, I think I told you those things in my last classes. But the point here is, this is the structure we have created here. Okay, and if I'm the git logs one line command, this is the information we have. Okay, this is my tree or my timeline or my branch, or maybe I can say this is a master tree, whatever the name you want to give here, everything is right. Now here, the important point here is, let's say I want to do further, and this is the last updated we have done. It is there in the production environment. Our plan is to create one more branch extra because I want to add extra feature. So I would like to add a new branch that's called dev1. Why? I would like to add new data, new feature on it. Okay, let's say I want to add d1 file. Okay, then git add and then commit. Okay, so what's the plan, right? Let me first create this particular, let's say d1 as a commit name. Okay, so what's the plan why I'm doing this? Because I want to create some extra lab here for showing you one interesting concept. I'm going to add all the files what I added here, and there's a d2. And let me do one more time. My developer also create some more code, some more changes they have done. They will add in the staging area. They will further commit. So this guys is how we create it. Now, in this case, the interesting thing is, if you talk about the entire history, this is the entire history we have. Now, important point I want to tell you here is, okay, why we create a dev1 branch, almost the region is same. Almost the region is same. Whatever things I added extra here by my developer one in the dev1 branch, this three history or three comments we added. So it's a extra history we added. Okay, every history we do something here, we do something in D2, we do something in D3, and let's say after we have done all the changes here. Okay, I want to merge this guy in the master. Why to merge, you guys know. Okay, but the challenge here is again upon use case to use case, requirement to requirement, having history is sometimes very useful. What I mean by this, when I merge, even though if I explain you from this graphical, when I merge, this entire history of day one will be added on the top of the master. Okay, means v1, v2, v3, entire node will add. Means in the master we have 1, 2, 3 history. There we have 3 history, or 6 history will have finally. And what is use of the history? We in the history, if you have b8, so we can go to at this point in time. If you have 6a, we can go to this point in time with checkout option or with some other options we have. Okay, so my point here is what I'm doing here. Okay, I'm going to merge. You guys know how to merge this, but before I merge, I want to do a small thing here. This is the workspace we created. Let me copy this folder as a backup folder, 13 into new folder, so I don't have to create again this thing. And because we are copying the folder is a Linux command I'm using here, and there's an option called R. Because we are copying the folder you have to create recursively. It's a pure Linux command, has no relation with the Git. Okay, this has been copied. Diagram I've copied actually, so I can use one more time. So in 13 workspace, we are in. Okay, so let me go to my 13 again. And you know what I'm trying to tell you here is, when you merge, let me go out, workspace 13. Okay, so when you merge, so how you merge, you first normally go to master. Because I want to merge in the master, we'll go to master first. And when you merge from dev1 branch, so entire history of dev1 branch, what we added, exactly history copied here. So we see here, exactly same history they copied here. Master has 3, now master has 6 history. Okay, so if I show you the history on the master, what you will see, the entire history copied here. This is from master, and this 3 d1 d2 d from dev1 branch now is a part of master branch. Here master is pointing to this, it means everything come in the master. Now guys, upon what I'm trying to tell you here is, upon the use case to use case, sometime I want my developer one entire history copy to master. And one of the reason is, if you have the copy of entire history of dev1, so I can go to any point in time. Okay, I can check what has been changed by developer here at this point in time. So I can say get show me, okay, what changes they have done here. Okay, best. So we can say at this point in time, my developer one, okay, added this comment d1. That's what they're showing you here also. Plus they added new file, some new file they added over there. Okay. There's one more thing I show you guys, or you can see the content also with cat files command. So having the history has a benefit. Okay, but sometimes having this entire history has no meaning. The unwanted increasing your history size, because bigger the history size is harder to search, harder to find what we are looking for. For example, a developer has created history and they keep on doing changes and they keep on committing the things, and after doing thousands of changes they commit and finally they create a final feature. Okay, so if you merge, then all those thousands of history will be added on the top of master branch. That makes master branch history is so big. Okay, and if the history is very big, so it's very harder in the terms of management. Means if I want to go here and there, I want to go to particular version, I have to search with time, I have to search with the name and lots of, it would be very harder. I'm mainly in the context of history management. So what I'm talking about, while merging, you can take a decision. The decision would be something like this. If you think what a developer one has done, multiple history they created and versions they created, I don't want to take the entire history from the dev one. I am only interested, okay, whatever the changes they have done, I want to take only the changes in terms of file, in the terms of content. That's all. I'm not at all interested in the history of dev one, dev, and their comments, other things. Okay. In all these 3 changes, whatever the content they changes, for example, they have added these 3 lines or 3 files or some content we added in this file. I won't have those content to come in my master branch. This called merge. But I don't want the entire history, come up in my master branch. Otherwise, it would be big trouble in the form of managing the history in the master. Okay, technically it's not giving the trouble in terms of storage management, because storing the history won't take much storage or the hard disk or the RAM, but only the challenge would be in the terms of management. Means if I want to go at one point in time, huge history come out, thousands of thousand lines, very hard to go up and down search, so tedious to manage, right? So that is a reason, guys, that is a reason we have one concept. What can we do? Instead, we take this entire history and copy in the master. What can we do? We can say this guy, I'm not interested in history. I'm interested on your content. What content you change here, here, and here, and finally, what are the final version you have? Take this entire data and add on the top of the master. Okay, and obviously we are adding something new on the master, then this guy will have a different commit over here. Okay, so instead of this 4 and 5 and 10 different changes, history, come to me. Final version, whatever you created, I'm only interested on those content and those files. Take the entire content, store in this new commit inside the master. So again, we are doing merging. It is exactly like merging. Same content is coming, data is coming, code is coming, but I am not taking the history of the dev one. Why? I will explain to you. This concept, guys, is known as merging only. But in this merging, we have to use a kind of, maybe I can say some kind of strategy or some kind of way of management. And this management is called squash. So we're squashing, okay, or squeezing, maybe you can say, this entire history and make it one single history. Okay, so it will be good in the terms of management of the history. It's sometimes very useful concept. It will help you a lot, okay, in the bigger project. Otherwise, your history becomes so big, harder to manage. Okay, so that is the reason I have created one backup file of WS workspace. I'm going to WS14. So I can show you this demo, right? So what I'm doing here, I'll go for different workspace that is called 14 here. And what I'm going to do, this is the entire history we have. There's 3 versions. Dev 1 has changed. So if we just go and check out the master or switch to the master, and if I run the git logs command, right now master has only this 3 history, but I want to merge. But what do you see, guys, this time? When I merge, okay, when I merge, git merge command of dev 1. But this time I'm merging, with the option called squash. Very interesting option, useful also. Now, if I do squashing, what you will do, what you will see actually, okay, now CEBA B9, this history of dev 1 won't add in the master. Okay, even though without squashing also, if I show you, I have these 3 files. But now the file of dev 1 comes to me. But as soon as I merge with this squash, okay, from dev 1 branch, again they are doing fast forwarding, because there's a fast forwarding merge. But the interesting thing that you will see here, they are doing squash commits. Okay, nothing you can see here. Okay, but your data come up here. So technically what we are doing, we are pulling the entire data from dev 1 and put in the master branch. See, guys, this data was not there in the master branch, but we pull from the dev 1 branch. That's called we merge in the dev 1 branch. Okay, and after merge, the history is not yet copied, right? If I again show you the logs command, history of dev 1, it doesn't come up here. Okay, but if you're on the git status command, now you can see new file come up in the master branch. So technically it is, you can think in this way. Okay, in very quickly concept perspective. So all the changes you have done in the dev 1 branch, we pull those changes and put in the master branch, where in the staging area only. That was they're talking about. These 3 files will be added in the staging area. Now, because it's not yet committed, and because they're not committed, that is the reason there's no one more extra node created. Okay, so that's what they're showing you. Data is there because anything come in the staging area, first they have to copy in your working area, and because they're copying in the working area first, this is then the file come up here. Plus they also add in the staging also area. So this file added in the staging area. Okay, now if you want to have this part in your master branch, so you have to do one commit here of all those data. Well, let's say squares merge, some name you can give. So I've commit. It means technically all this file, or I can say the entire history, not history, the data that Dev1 has changed has been added to the master. Okay, and where they added, technically look like all the CE, BA, D, B9, 3 history has been copied in 3.4, this new one. How? By this command. This is how it was. Very powerful concept, very useful, is squashing concept. In the GitHub also we have this option. I'll show you. Normally or mostly we do sometimes squashing there, okay, instead of the merge. Okay, but this is guys called merge with squashing. Okay, so now my history is, there's nothing to commit. We have a data come up from a dev1 branch, and plus if you see the logs also, only 4 we have. Maybe guys, this in this particular point in time, lots of data come to us, a lot of features come to us, but from the dev1 branch, and that dev1 branch might have hundreds of thousands of history, but everything is squashed into one. That's the idea of squashing, or useful. And after this, we don't need any dev branch. We can delete the dev1 branch, because whatever they have done changes, we already merged into the master, merged with squash, so we can change. Very interesting concept, guys. Very interesting. This very interesting scenario, I can say. Okay, now because we have done squashing, so they become confused. They say dev1 branch data is not merged. Okay, but actually we merged. And why they're saying this? Because you're trying to remove the dev1 branch, and they see in the master branch this CE, BA, B9, this history is not available. So that is the reason they think it is not merged, but it is merged because we use squashing. Because in this squashing, we don't have to copy the history. So this is in this command confused, that give the error, but it's not ever error, because you have done by yourself. So you know the concept, what you have done, and you're pretty sure the entire data has been copied. And because you're sure, then you can delete this branch forcefully with the option called -d. You can sure if you want to delete, you can delete this with the option called -d. So now this branch has been deleted. And now we have nice clean history. And this again, the case, because this data is, this CE, B and B9 is being managed by dev1 branch. So dev1 is the head, or dev1 is a branch where these guys are managed, these node are managed, but this branch deleted forcefully. So these guys become unreachable, or they become orphan node. So these guys we can't see from the logs command, orphan nodes. Okay, so CEBA is not visible, but if we use the reflog command, we can see these guys exist here. Okay, CEBA, CEBA and B9. So if you want to use, you can again check out and start using somewhere, connect to somebody with a checkout command. I show you already. Or if you think now everything is done, check out and got data copied and merged, so you can clean it, right? How you can clean with a GC. So I can say git, just use your garbage collector, and I want you prune the data till now. So whatever the orphan node you have, unreachable node you have, go and prune it. Okay, it means just remove this node permanently, right? I don't want this guy to be in my commit area. So they do, but this time you see guys, nothing is changed. Okay, because GC guys behind the scene doesn't know which part to clean, to take a garbage collector. And that is one of the reason, because I just run this command first. That is one of the reason we have to first use this expire command. So the command that I showed to you already. 1 minute. this expire command. Okay, what this command will do, they will go and check all the unreachable node till now. All internally they tag something that now these are the expire node because they are unreachable. Anything that are unreachable and now become expire. Now this time if I run the gc command, so this is what will check whoever the expire is, and then there's been the git has been tagged somewhere, they will prune, and after the prune you can see this will be removed from the commit area. Okay, now you will see guys they have been removed from the commit area. I just want to revise this command one more time because not some of the guys has a understandable, they wanted to again discuss, so I just want to explain you one more time. But guys, this is the concept of called squashing one topic, very important concept. I explained you with the use case and it's done. Let me create one more scenario here, the same example. So what I'm doing here, right? Let's say, let me add one more new file, and let's say file would be n1.txt. One file we added. Okay, let me add into my staging area. Let me add this file, and let me comment this file. What we have in the staging area into, let's say, new file one added in my commit area. Okay, the new file will be added. So 6c8a will have this new file non n1, and my comment name is also n1. Okay, now this point in time my history is clean. My history is clean. Okay, nothing to add. Let me add one more file. I want to show you something. N2, add N2 in my staging area, and one more comment I want to add very quickly. Let me add one more file to create particular, real kind of scenario I'm trying to create here, and N3. Okay, so this is a history we have created. Now what I want to do right now, my status is clean, nothing is to commit. It means whatever data I have in my working area or name or repository, all the file has been added into the staging area, and then they go to the commit area. Or maybe we have an ignore file, some of the file may be ignored. So it will be anything, but technically my status is clean. Okay, clean. And we have these many history we have, or maybe you can say these many history we have right now. Okay, now what I want to do here, is whatever data I have at this point in time in my history. Okay, or I can say in my commit area, I want to take this data back to my staging area. Again, I'm repeating. Okay, last time guys I added n3.txt file. That's what I write the command name also n3. So whatever data I added, okay, in this commit area, I want to take this data out from my commit area to the staging area. Okay, that's what the plan is. Okay, so technically I'm asking my my commit area that I want to reset you. Okay, I want to change on you. Maybe you can think in this way. Okay, so means whatever data you have here in the commit area, I want to take it out and put in my staging area to make you this concept very clean. Let me explain you in this way. We have a working area, we have a staging area, and every area whatever data we have a commit area is like a backup. We can roll back, we can go here and there, and whatever data we have the commit area, okay, those data only will transfer to the GitHub, and the area will transfer to other branch. Okay, so the commit has a lot of use cases. Okay, staging area, you guys know, to track the files, other things staging area do, and working area where we as a developer or software developer work here in the working area. But right now all the data is there in my my commit area, okay, as a backup copy or as a snapshot. So what I want to do here, I want, let me run the status command one more time. Everything is the commit area, because they are clean. My tree is clean, nothing to commit. Okay. So what can we do? We can tell the Git, all right, that there's something in my commit area. I want to take it out because so sensitive, because this is one file, let's say the n3.txt file is there. Okay. If I don't take it out in my staging area, so what happened, as you start push the data to GitHub, this data also go to GitHub. But this file I committed previously, but I thought there's some bugs here. I thought there's something to be done more. Okay, so I don't want to take this risk here. So I want this file again come back to my staging area, and obviously it's coming to staging area. It will be removed from your commit area. So by chance somebody do push and something happened, create a new branch, this data and this file won't go to my GitHub. Something like this. Okay, now it's one single file, or maybe whatever you done in the last comment, it will be everything, right? So that's what you can mention here. So we can tell my Git that I want to reset. So okay, I want to reset, okay, my last commit, and last commit is known by this number, or you can use by head, whatever you would like to say. Okay, go to last, but technically you don't want to go here. Last would be this one, because this is what changes you have done. You have only committed. So you want to go back, this will be your last. So you can give this number. Either you can do in this way, or you can use tilde1 is the same thing. Okay, because current node or current commit is known by head 0. Okay, second last one, either you can use the name 97, but this name is always changed in every repository. So better would be one I can use. What is this? I told you in my last class. So we are resetting to this node 97A5. It means my head is pointing toward this. You can think in this way as a logical perspective, but technically what they're doing, whatever data you have at this commit, you have 10 files, 20 files, some file edited, some file removed. Everything will be rolled back kind of concept over here, and we move to end. So after we run this command, now you can see, guys, this visual is so powerful. Now my head is now moved to 97 here. My head master moved to 97 in the graphics, and this guy is not yet connected to anyone. So they become the unreachable. We can use it with the checkout command. There's a different point, but it has become unreachable. Okay, but in this case, what happened? Okay, what happened? Now, if I run the status command again, you will see, okay, your file is now come back to your untracked file. Okay, untracked file. So when I use this option, what happened? They say now file is untracked. Okay, means if I run the status command have as, means you can think it is something like this. This is the file is not known by Git yet. Okay, now it's coming back to your working area. Okay, so this file come back. Technically, guys, this example by chance is a little bit different example. In this example, what happened? What a last commit has done. In the last commit, guys, we have copied this file. So this file is removed from the commit area. Plus the tracking of this file also removed from my staging area also. Again, this file come back to your working area. Okay, and it look like this is the first time we have seen this file. The file is not yet tracked. This maybe it look like this is a new file you have created. You as a developer still working in your work area or working space on this file. Okay, and even though you get one log, one line, get log, one line. Now you have been pointed to this. But the last committed that you have done was this one it removed. Why I want to do this? Because I accidentally put in the staging area or my commit area, or maybe after putting the commit area, I come to know I wanted to change in this part. This commit area I want to remove, or this commit object or commit ID I want to remove. So you can think in this way also. If you want to remove the commit ID, what we committed last, this is also one of the way you can think of. Okay, so now it's come back as a normal file, the way you added initially. Initially when you add a new file, they show you this symbol question mark is a new file. And this new file, whatever changes my developer want to do, they open this file, they put new data after changes. Okay, where they put, and then they will add again. After the add, they will again commit. Let's say M3 new data. Okay, and after the commit, again. So technically what we have done, we initially created D600 commit area. We remove this commit area, we can come back, everything come again in this initial go. That's called working area. Again we do some changes, again put in staging area, and then commit a new history created. And now this become again orphan node. You can guys know how to do a GC garbage collector to clean this node. Okay, but in this case, if you have this kind of requirement, what is the use case I'm talking about? In this requirement, we use reset, and this kind of reset is known as mixed reset. So either you write this or you don't write this. This option they have also mixed reset. Okay, so this example is known as mixed reset. So if I show you one more time, okay, so in my logs, this commit ID contain new data. That means they contain this file with the data. It means if I do git push, or if I do git check out new branch, let's say dev1, entire data will go to dev1. This also go with the content, with this content. Okay, but I don't want, maybe I don't want this commit will go to my other branch in the git push also. Okay, so that's what we wanted to do here. I want to reset and take my data back to my working space. Okay, so let me very quickly delete this branch. Just wanted to show you. So I don't want this data will go, or I can say in the simple way, I don't want my last commit will go anywhere. Okay, I want anything we push or we create a branch, they will take this data. I want to work in this part. So for this we do reset. Okay, but this reset is called mixed reset. If you write or if you don't write, by default reset is called mixed reset. There's two more type of reset we'll discuss, and we reset back to which position. They can decide to do 1 history back, 2 history back, 3 history back. Maybe you want to reach here. That will be your choice. Okay, let me go to 1. Okay, so by default is a mixed reset. You go here, your head will go here. Okay, and now what you have here, if you see the status, this will again come to your working area, work on this file, again add and commit. That's what you can do. So this is guys called mixed reset. And there's one more kind of reset, it's called soft reset. Let me tell you, there's 3 different kind of reset we have. Okay, almost they're working in the same thing. Anything that you add in the commit area, and from the commit area you want to take your data back. Okay, obviously where, either in the staging area or in the working area where you want to take it back, that will be your choice. But anything that you committed, you can go to any commit ID. Okay, and that part you want to remove from the commit area, or want to take back in these area, either this one, the way it is, that is not been committed, right? Then we have used reset. Okay, one of the reset that I showed to you here is called mix reset. What mix reset do? They will remove all the thing at that point in time of my commit ID, remove from the commit area also, or they remove from my staging area also. They remove from here and they also remove from here. Okay, so at this point in time, what are the commit ID I'm using here? Maybe ID, or maybe I'm using head, last one, last two. Okay, that reference or pointer. At this point in time, what a file we added or what a data we added, they remove from the commit area, plus they also remove the tracking from the staging area, and they come in the working area as is. And so we can start working from there. That is a idea of this mixed reset. And now, because if you see the logs also, okay, so we are pointing to N2, means here. Now, in this case, if I do git push, if they're pointing 697, if I do git push or git new branch, only this data will come there in the new branch. For example, if I go to dev1, dev1 already exists. If I go to dev2, in dev2, only data that exists till 97A5 will come here. Yes, 97A5 come up here in their commit area. But this is also visible because it's a part of my working area, because this file is not yet committed. So this file is again still exists. So it's like a working area actually come up here. But this file is still not the part of my this branch. Okay, but these files are the part of my dev2 branch. Okay, so my dev1, dev2 is a feature branch. They work on this file, they commit in their branch, or they merge, or we directly work on the master branch. We edit, we put in the staging area and then commit. Depend on what's your plan for further management you want to do. But in simple term, I want my data in this time or in this commit ID. I want to take this data out, okay, from here and from staging area also, and put in my working area. That was the whole purpose. Okay, so this is one idea. Now we have some more kind of reset depending on the requirement. Let me first go out. Let me switch back to my last. There's no branch expected got commit because nothing is committed. So let me use this command for checkout to go out to master. The thing is, there's some file has been untracked in the working area, be overridden by this. So before switching, you just remove the file to switch. So better, let me add also remove. Let me add commit dot m dev2 dev2 added this file m3. Let me switch to master or here. Now what I'm going to show you here is okay. First, let me clean this entire data so I can show you very clearly. So let me clean this entire tree or my repository. Same thing. Git branch. I want to delete dev2 branch forcefully. Okay. And I also want to delete this branch dev1 forcefully. Okay. Then to clean, there's some orphan nodes we have. So I will call this expire again, and we'll call GC collector, garbage collector again. So everything is now very much clean. This is the data we have. Okay. Now what I want to do here, so this is the data we have. And everything we have in my commit area, everything is clean, nothing to commit, everything is clean, nothing is to commit here. Okay, and we know we have added some new file here at N3, here we added N2, here we added N1. Okay, and all the data is there in my working area. all the data is also there in my staging area, and internally they are stored in my commit area also. So again, I want to do reset. Again, I'm resetting back to my one history back. So this is 0. I want to go at this point. If I hit enter, they will use mixed reset that I will explain to you. Okay, but instead of mixed, I want to go for soft. So we can pass the option called soft. So if you don't pass the option, by default option is mixed, but you want to go for other reset, you have to use soft. Okay, so what soft will do? You guys see here, my nothing to commit, nothing is there in the staging area to commit. Okay, and all the files in my working area is already there in my staging, sorry, in my commit and the staging area. But if I do this thing, okay, soft reset, if you see here, okay, first of all, my head start pointing to 97, second last one, because I asked them to reset to take me here. This is one thing. Okay, but what soft do extra, what mix is not doing? Okay, so in this case, right, if you run the status command again, in this case, you use some difference here, and the mix, they were showing you question mark, but here they're showing you A. Technically, what they're doing, if I run this option here, they are remove this data from the commit area, but they put this data into the staging area. Okay, that is what, guys, the soft reset is doing. So they say, I'm putting your data back. If you do soft reset, I'm putting your data back, remove from the commit area, but data will be still exist in the staging area. And because they're still put in the staging area, it means some of my developer working on this file in the working area, adding the code. So I know how to track this. For example, I know because this file is there in the staging area. You guys know use of staging area. If I add something and somebody adds something in this file, let's say new test, they added. Okay, so we know how to track this file. We can say this file has been modified. Okay, because this file is staging area, we know how to track this because we're tracking, so we know this file is modified. Or you can use S option to check if this file is AM. A means it's still there in the staging area, is not there in the commit area. M means it's still in the staging area, but somebody in the working area has been modified. So this is called AM flag. So guys, in my initial class, I talked about in the staging area, we maintain multiple flags. So these are the flags. A means this file is added in the staging area, but not in the commit area. M means this file has been modified. Where? In my working space, or work area, or maybe the working area. Okay, so this is what, guys, they are doing. And why we want to do this? Because I don't want to keep this file in my commit area, because if we put this file in the commit area, so what happen if anybody push the data, this file will push to the GitHub, or anybody do a checkout and get a new branch, this data also go to new branch. So I don't want to share this commit history or this commit data to anyone. Okay, I committed initially, maybe externally, or we committed like with nothing technical reason, but we committed. So I want to take the data out, so that somebody will push, so it won't go to GitHub and some other places, or it won't go to my production environment. So I want to do more changes in this part. Okay, so that is the idea. But if you think you're good to go, just again, because now there's no requirement to add. Okay, requirement to add this file, so we can actually go and commit this file. It's already there in my commit area. So N3 added after soft reset. This is one comment I'm doing here. Edit. Now everything is clean, nothing to update here. And if you see the logs history, now this one committed, new commits come up, right? And this again, there's no use of this because we already reset this guy. So again, you can call expire to expire, that is not reachable. and then ask the garbage collector, go to my commit area. Anything that is not connected, it's been tagged expire by ref log, just go and clean this part. So guys, this is what the reset soft is doing. Guys, according to my knowledge, if you see any of the videos in YouTube or some other training or in blogs, this topic is very confusing, right? I'm just trying to make this topic very clear to you with the right use cases. Main thing is in which use case what to use. There's a main thing, right? Otherwise, setting anything like reset makes or soft it look like same, but if you understand this concept what I'm trying to explain to you, that makes more sense. Okay, so rather than you memorize this mixed and soft, you just think what you want from the commit area. I want to remove the file, plus staging also you want to remove the file. So I don't want to track, I want to give a flavor that is like a new file we have created, something like this, and then go for mixed. Or this use case you want to just remove from the commit area, you still want to track the file in the staging area. It is something like this. We have done git add kind of command, so that kind of flavor they give to you. Okay, and after everything done properly, then we can commit in the future. Okay, so that is if you know this concept, then properly you can use when to use soft and when to use next. Okay, and then we have one more kind of reset called hard reset. Okay, very dangerous this one is. Okay, what I mean by dangerous? Okay, so it without using properly this option, it will create a lot of mess in your working area. What I mean by this, so right now everything is clean. Okay, this file, all this file data is there in my commit area. This file data is also there in my commit area. Okay, this data is there in my commit area. Okay, now this is a working area. This folder is working area. My developer is working in this file, and let's say they added some more new data in this file. Okay, let's say new data by some data they added in this file. Okay, and because this file has been tracked by staging area, so the component new data has been updated in this file. So if you run the status command, so they say the file has been modified, because we are tracking this file in the staging area. The staging area say this file has been modified. So if you want this file to store in the commit area, you can commit it the way you commit. But here the requirement is different. What I wanted to do, okay, whatever data I have in my commit area, I want to remove. That's what the reset means. I want to reset my commit area. Okay, or in simple term, there's some commit IDs I want to remove. Right? This is also one of the way you can think of. But technically it's what reset. I want to reset my commit area. Okay, but if you use the hard, what happened? So right now, this is my current status. Okay, and this is the my log history we have. Okay, and let me show you my graphical also. Now, if you do reset, okay, again I'm going back one head up. That's this called one head back, I can say, or one head down, maybe I can say, to this guy. Okay, with the hard. Okay, what happened? Now your head is now connected to this one 97, one head down. We ask one, same kind of look and feel you see in mixed and soft also. Okay, but in this context, if you again see the status, now status is cleaned, and this is very dangerous. That is one thing. We reset, and after reset is clean. But even though guys, in my in my soft reset, okay, in my soft reset, when I have done where I've done the soft reset, right? I don't know where. So they show this option. In my mixed reset also, they show you something is not clean. But if you do the hard reset, you know what? Showing after doing hard reset is being clean, means nothing to commit. Okay, So what I'm talking about, what they have done, okay, and why they are very dangerous. All right, if I show you here why they are very dangerous. Okay, if you just look at this diagram or this page, what hard reset have done. Okay, whatever changes we have done at this point in time. Okay, and whatever change we have done at this point in time, we know the difference with the differential command because there are different snapshots or copy we have. But whenever you do a hard reset, okay, this commit data what we have at this point in time, let's say this is a 1 and let's say this is 2. So what are the commit data we have on the 1, they compare with the 2, this is called differential. Okay, and what a differential we have, it means those things we have changed. Okay, so what hard reset do, hard reset will go directly to your working area where developer is still working, they are developing the code, maybe right now on the real time. A lot of interesting things they've added in this working area. What they do, they will go and remove all the differential directly on the working area to give you illusion that that has not yet been added. So what is dangerous about it? Let's say I am working directly in a working area and I'm doing some code, I'm writing some features, one new function method classes I've written in my code, and somebody accidentally run the hard command. What happened? All the things that I've done till now will be reset back directly in my working area to this point in time. So what did I had at this point in time will reach there. Means all your current working we will lose, or you lose your current working, you won't get it back. That decision is very dangerous to use, but sometimes useful. Sometimes useful, it is something like this, like kind of rollback. Okay, because maybe as a developer I've done a lot of changes. Okay, and those changes I'm not happy with this, or my command, my programming working has been corrupted maybe. So I want to roll back my working area, okay, and reset my working area at this point in time. So I will see my code, what I have at this point in time. For example, at this point in time, I don't have n3 files here. There's no n3 file. So this n3 file removed from here, even though I changed a lot of things in my n3 file, but this entire file be removed. So at this point in time where I reset, all right, that file was not exist. So they removed entirely from my working space, or my current directory or my repository. So if you want to see the entire look of this that point in time, okay, in your working area directly, you can use. Okay, but guys, in the soft and the hard, it won't work in this way. They are not touching your working area. Neither this guy is touching your working area, neither this guy is touching your working area. Whatever you have the working area right now, at this point in time, we're doing mixed and soft. They're not touching your working area. They're only removing data from this commit area, or maybe from a staging area or not. Okay, but hard is actually removing your data from the commit area, removing data from the staging area, and also removing from the working area. It means there's no backup copy of it as such. Okay, there's no backup copy of it. Plus, my developer is working maybe in the ID, some of the developer tool, entire data will be removed, flushed off. Okay, if you want this, maybe sometime you want, one of the example is something crashed, code is not working, I want to roll back as entire backup, like undo kind of thing, right, of entire project. So hard reset is good in those part, but accidentally, if you've done the hard reset, sometimes I've seen a lot of guys are doing this practice, is very, very bad practice. Okay, don't do this, otherwise you will lose your data. Okay, that's one things. And because they remove the entire data from the working area, that is a reason there's no issue in the status, because the file is removed, nothing is visible, nothing to edit, because everything is rolled back. So there's no meaning to have any issue in the status command. None of the status flag is commit and question mark and like a modify, because it's removed. That was the reason they show you very clean status here. Okay, So there's all these three reset I explained to you with proper use case and practical, but is very, very critical to understand when to use what. Okay, and because we have the versions, multiple snapshot, multiple commit IDs, we can reset any point in time, depend how and what kind of reset you want to use. Accordingly, you can use. That's one thing. But hard reset is very dangerous, but because of the internal management of your what I say of the Git, I can say, okay, because whenever you reset, you go back to 1 or 2 or 3 head. Okay, you go down to particular head, and those node is not internally deleted. Okay, internally deleted means this node is unreachable, but is exists in your staging area. This node is DBB, is not a part of your tree or your head or master timeline. So you can't see this node BDDD in your BDD, DBBD or something in your master timeline or master branch. But Git keep this node with them. One of the reason is to save ourselves from accidentally reset kind of thing. Okay, so Git say if somebody have done accidentally this reset hard, you will lose your data. That's what I've done. You lose your data from your working area. In this case, you should have something who will help you to reset again. Maybe this was what reset we have done accidentally and I lose my file, but I don't want this, but accidentally I've done this. So this unreachable node will help you. And that is one of the reasons why we don't we don't do garbage collector automatically. We have a concept in Git where we can run garbage collector automatically, means this one automatically as soon as something goes unreachable, do the garbage collector. But if you do the garbage collector, this will remove. And in this case, if something accidentally happened, that's what I'm talking about here. Okay, then there's no way to get your data back. So good practice is, again, depend upon requirement to requirement. If you think this kind of scenario might happen, so don't run this garbage collector. There's some technique that garbage collector automatic run always. So don't run automatic. This two command is take a practice, just run by yourself manually whenever we need it. Okay, or we can schedule this thing also. This come by some kind of job schedulers in the market and say run this command every 1 hour, 2 hour, or 10 hours. So that's the different point we can do. Okay, but interesting thing is, let's say I have done my hard reset, this one accidentally, and my data will remove from all the areas. My N3 file is not there. So how can we get back this file? So we have this node available. So what can we do? This is the command I show you. Now we can take the power of checkout command. Checkout, I say this BDBBD46D, this information we have. I want you take my head to this point. So the head will go to detachable mode. Now head will go to one of the node that was unreachable. Okay, so this head come, and as you reach to this head, you get your data back. You get your data back. Okay. Now in this case, but normally head is just a pointer that will tell you the current point. After I close this my system, open the close my terminal, again you connect to master. Or maybe reboot my system, they connect to master. If you go to other branch, again to come back to master branch, they again go to master. This node will again become unreachable. What I mean by this, okay, let me very quickly go to some other branch. Devon branch, your head will go to Devon branch. Yeah, Devon branch. But if I again go back to master, you again connect to master with this 975. Or maybe Devon branch, somebody want to remove, maybe I want to remove forcefully. Again, this become again unreachable. So what I'm talking about, okay, checkout option on particular commit ID is temporary. Again, head will again go back somewhere else. So that is the reason right now you don't have a data of N3. Okay, so when you do checkout or connect to this particular node, data will come up. Okay, but you have to make this data permanent save, where maybe you want to save in the master branch. So how we can do this? Simple, right? After head come up, we can store first this data. Okay, even though if I see the get status also is this point in time, get status, everything clean because everything is committed. It's also committed, so it's clean. So, but my point here is what I wanted to do here. I want this data to be stored in master permanently. Okay, and normally you want to store in the master branch, you have to commit, but nothing to commit here. Everything is clean committed. So how to commit? Okay, nothing to commit. So in this kind of scenario, one of the simplest way is to just again create one more new branch. Let's say dev1 branch. And you guys know when you create a new branch, all the data where head is pointing to go to dev1 branch. So technically, this data will go to dev1 branch. Okay, now we are in the dev1 branch. You can see get log one line. So this branch have this data B D B B D. This data they have it. And you guys know whenever any data come in the dev1 branch in their tree, you can merge back into master, not big deal. Now I can go back to again master and say master, I want to merge some data from dev1 branch. Again, they merge back. This data again come up. Now you're in the master branch, you can see your data is still there. So it's small thing is very useful, you know. Sometimes accidentally it's happened, right? And it's not a small thing, it's very critical, right? Because you might lose your very powerful code and concepts and logics, right? In doing some kind of reset or hard reset. Reset we need to go back, see what happened, right? But accidentally having wrong reset will create multiple challenges. So you should know the approach. So I just explained the entire approach, the challenge, then how to resolve this. I also explain you that point right over here. So this is the one quick idea and information to you. Okay, so I explain guys this reset concept in very much in detail. One more concept I want to explain you more look like this, but has a little bit different use case. Let's say this is my N3. Okay, file. In this N3 file, let's say I want to add some data. Okay, let's say B1 new data I've appended here. I appended, so let me commit this data with B1. Okay. So why I say B1 so is M. Okay. And now let me add some more new data in this file. Let's say B2. Okay. And again, I do commit here. So everything is clean. Nothing is here. It's been clean. Nothing here. All right. So what I want to show you here is whatever data you have in N3 file, okay, in your working area, exactly same data you have in your commit area in 067. Okay, that's what you have. Now, what happened? Maybe let's say I want to add some more thing in my N3, or let me open my file N3 with some text editor like VI, and let me delete some data. Add some new data, So I added some new data. I'm doing some coding change here, code change here. Obviously, this file modify. You can store this, commit this file again in your work commit area. Sorry, okay, from the working area. But maybe at this point in time, this file, whatever the code I want to change, has been corrupted. I don't want to use this code. I want to reset my code. I want to roll back my code. Okay. And now you decide you want to roll back at which point in time. You want to roll back at Geo67 or DD82 or BTD4 97A. At what point in time you want to roll back? Okay, only this file. Okay. So, or maybe you can think in this way. Maybe think in this way. This file has been corrupted. Okay, in my working area, and this file is still modifying my working area. I want to reset because what I did at my last commit, I store my file in Geo67. That was perfect. So it is something like this. You are doing your code. Okay, doing your code in some kind of text editor. Okay, and what is code you want to do? You change. You want to undo the entire code till the last person. This is very common use case where the developer, wherever you commit, normally we commit always after successful thing is working normally, and mostly I can say. Okay, and then start working on the code and something is not working. You won't be able to figure out the challenge, what and which part of the code my thing is not working. So one quick thing you can do, you can reset or undo the entire code till your last commit. Okay, so this is a working area. You have to commit to last commit. So for this, again, we have a get checkout command. That's what I'm just talking about. And just give your file name. That's it. Just give a file name. So what happened when you give a file name? Okay, so what they have done only for this file. Okay, guys, see here, nothing has been changed in my tree. Nothing, none of the node go the way you see in your what I say, in your reset things. None of the node become orphan. Okay, what this checker has done. Okay, whatever change you have done in the working area, that has been removed and they'll be reset back to what you have done in the last commit. Means this is the data we have changed and updated. Now this data has been resetted or updated to your last one. This is the last one, is the same data what I committed at Geo67. Okay, and this data was the one who was working fine perfectly at that point in time. So we reset it back, and after we reset it back, these guys, now again I start working on my projects further. So checkout is a great option. Multiple things they do. They get a branch, do something on the branch. They take you ahead some point in time. Or checkout will also help you in this context also. Multiple things. Checkout is useful, very powerful command it is. Okay. And then guys, one more very powerful use case. This is a very common use case. We keep on using this command again and again. Okay, to reset our entire code back to the last commit. This is what and how we use. Okay, so this is guys one more thing. Let's quickly go to GitHub and do something on the GitHub again. So what I'm going to do, I'll go and I'll just create git init, and in the git init, where it is git init, let me create one more new workspace, 15 new. Okay, and what's the plan? So plan is something like this. Now this repository I want to sync with GitHub, that you guys know very quickly. Let me do it. Okay, so this is a new repository, and in this new repository, okay, let me create some new file, cat.a.txt or some data, and I would like to add this data in my staging area. Then I want to commit this guy in, let's say, command called FFF or AAA kind of commit. Okay, but this file is there in my working area. I want to sync this file with my what I say, to my GitHub. How we do, we go to GitHub and create new repository. The way how we create, you guys know. So there's a git training, spelling might be wrong, test 111. Okay, we're creating publicly. I don't want to initialize over here because it is already created locally. I want to sync with this guy. I don't want to initialize. We discussed already in the last class. For sync, the guy say is go and create this thing. This is what we have done already. Commit we've done already. Okay, branch we already have. We will only do this with SSH. Well, last time, guys, we have done the SS setting. So I will run this command. This command I'll explain you guys in my last class. So in my right now in my remote, I don't have any remote setup. Best. So remote setup has been done. Okay, they say whenever you do push, your data will go to GitHub at this particular account and this particular repository. Okay, but which branch you want to send? You might have multiple branches, but I want to send my master branch, so I can write this command. The guys I explained in my last class again. So my master branch go to my origin. Origin is the information of where you have your URL. Okay, I'm pushing this thing. So origin will be my upstream. So that this concept I explained in my last class already. Okay, this is uploaded, and that's all. So this concept we have discussed. Now after we refresh, thing will come up. So till here and lots more other options we have discussed in my last class. Okay, but what you see here over here in your graph, they are very clear. So they're also showing you now at this point in time, this 567 is being connected to local master and origin master. So they will show you both thing here. Okay, so FC5 is connected to this origin. Data is origin. They show you here in this visuals also. Okay, now what happened? Right now my Git status is clean. If I do some more changes in this file, okay, we can say the status, something is modified. Let me commit. Okay, and guys, when you do commit, they commit always in your local system. Okay, so now from here, it's very clear. My local system is one version ahead of the origin. So this status say nothing to commit, but if you run the status command without S, right, where S only show the flag, they're very clear that your branch is ahead of the master by one commit. Okay, master origin means the GitHub. Okay, so in this case, what can you do? You can do push. So for pushing, you don't know now. You don't need to use this option again. One and initially you to use, because after you have already done, they will maintain internet. I'll show you the command in the last class. Now you have to do just get pushed to send this guy. So last version was one commit and a push. So this is also updated here. Now GitHub and local both is connected to 6B. So if you go to GitHub, okay, and if I refresh here, you see both the guys will have a same two commits with 6BC, same thing they have. So this is the scenario. Okay, this is a scenario where, okay, where in local system you're doing some changes and then uploading into the GitHub. Okay, but there's a possibility that somebody is directly working on the GitHub doing some changes there. In this case, okay, if you're doing changes here, so if you want to sync with yourself, then in this case you have to download this change in your system. That's called pull. Okay, that's called pull. How we can do this? Okay, so maybe one of my team member, maybe I don't have my laptop right now where I have created this repository, but I have the internet access. So I go to internet from some other laptops or working space, or maybe some cafe. I'll go here in my repository and log in, and I think there's some kind of critical issue come up in this file. So I click on this file. There's option here to edit. I edit this file and I write change by from GitHub. Okay, so I added some data here, and then I commit here in my master branch only. Okay, the change. So technically, according to GitHub, you have 3 commits. This is the last commit ID that GitHub know. All right, GitHub no. Only GitHub no. But this GitHub is a very different system altogether, and laptop is very different system altogether. Okay, in this at this point in time, if you ask to your local system, do you know, do you have any, we have some changes here? They say no. Okay, according to me, my branch is up to date with the master, okay, or the origin. But this is not true. This guy think the latest version we have is this one, 2 commits. But technically in my origin, some more commit we have done. Even though if you see this visual also, according to them, they are connected to the same 6B. But now Git origin is ahead. Or your local system is one node or back. Okay, they are backward. Okay, with respect to Git, but local system doesn't know. Like I changed in my GitHub. GitHub is a different system altogether in the cloud. My local system may be shut down. Or my local system doesn't sync automatically with them. So my point here is I'm talking about. Okay, if you think sometime you work here, sometime you work here. Okay, in this case, if you think you do some changes in the GitHub, okay, or maybe some of the developer of my team might change in the GitHub directly. So it is good practice when you start working in your local system. Okay, before you do some change in the local system, you start coding in some or changing some file, always go to GitHub and say, does you have changed something? If yes, just give me this information to me. Now there are 2 things. Okay, you want only the information that something changed or not, or you want entire data with the information. Okay, so if you only need the information that something changed or not, if yes, what is a version ID or commit ID, how much change you have done. Okay, if you want this information, then we have a command called fetch. We can only fetch the information. But you know, if you want no, I need the entire information and the data also, files also, content also, then you can use pull. Sometimes using pull directly is not good practice, because if you use pull, they will get the entire data to you, what a change they have done. But maybe in my local system, I don't want to have those changes right now. I don't want to update my local file accordingly. Okay, before I want to check something changed or not, then I can take a decision that I want to sync with the data of GitHub or not. Then we can accordingly use pull. Okay, so what I'm going to do here, according to my local system, everything is clean. But what I do, I just use git pull command. So fetch command, you can use pull also, but a better way is to use fetch first. What fetch will do, for example, right now, if you see your local file has only 2 lines. Okay, this is the data you have. But if you run the git fetch command, okay, you will see the difference also here. The fetch command, you're going to the same remote system that you connected. Okay, you're going to the system, same account or the same master branch. And what you fetch the master branch or the origin branch. Now if you see the status here, okay, now you see they say your branch is behind of the git master. Git master. You know, we can see also here your local branch is at 6B and your master of GitHub is 4131. See here, 4131. It means you are behind. That's what they're talking about. You are 1 commit or 10 commits behind the original master. Only this information come up, right? Because we're using fetch only giving you the information. Okay, but if you see the data in the local system, it is not yet updated. What data we are adding here. But if you think you want to get data also, now you can use pull command. Pull. So pull will now get the data from the GitHub. Okay, so they're done. Get the data again. They're doing fast forwarding merge, means because you know GitHub is also like a different kind of branch, so their data merge in my local master branch, right? That's what they're showing you, fast forward. Okay, and now in this case everything is clean, up to date, right? And now your data come up. So depend Even though you can actually use pull also, pull will have both the capability, they get the info and the data at the same time. Okay, so mostly somebody will use pull a lot, but I recommend better first to use fetch, get the information, see what is happening. If you think that is what you wanted, then only you merge or pull the data in the local. That's what, guys, the use of fetch and the pull we can use, right? This is a one thing. One more information here. Let's say this is the repository I've created, and because while creating this repository, I make this repository public. So anybody who know my URL, they can download, even though without knowing my private key of SSH, they can download. Okay, in the local system. How? So here there's option called code. In the code, they'll tell they will download by SSH, or maybe they can download by HTTPS also. Because it's public, you don't need any kind of private key. So by knowing this URL, I just copy this URL and can download. In this case, the entire repository with data, all commit, my commit stream, my entire repository, all the staging area of these guys will copy to their system. So let's say this is one new system we have, and somebody want to work on this project. They come here and they can copy it. This kind of concept, let me copy in my other folder. Get WS workspace space. So how to copy? There's a command guys called get clone. That is the use of the clone. It look more like pull, but it's not pull. Okay, pull, instead of pull is clone. Clone means that we are copying the entire data from the scratch as a normal user of this code, right? But the pull, normally you use authentication, right? So maybe I have a data, okay, and have in this project, I know the login and password. I can also post. I know this authentication, something like this. So small difference, but you can think clone is something like anonymous. Anybody can come. If they're public, they can clone and download it. Okay. So if I hit enter, they're cloning this entire project in my local laptop. All right, and they create a new folder here with the name of my repository, same folder they created. And if you go inside this folder, in your other systems, you can see the data will come up with the entire history, status, everything gonna come up with the entire information, even though they will also maintain the remote information also from where you are uploading. Now this guy will work here and they want to upload, they can push, but in this case, for pushing, they need login and password. If you know the login and password, my private key, that you can push, otherwise not. But you can still work on your local system. So clone is a very common command. Mostly you guys might know this command because in those who know Git and GitHub, this is one of the simple command mostly we always use. Okay, so this is one use of the clone command. Now let me close this. Nothing very technical. This is one thing. One more a small thing, maybe that's what you know already, but I just show you one interesting concept. Not interesting, but useful concept, I can say. Okay. It will be something like this. I create a branch, get checkout here, and let me create a new branch called dev1. And dev1 branch, we change something in this file. Let's say DDDD change we have done. We commit this. Dev1 committed. But this file, guys, this branch is there locally only. You're on the get status. This branch is committed, but because this branch is not there in my GitHub, so nobody's here track and nobody talking about the GitHub is one behind or you one ahead, something like this. So you do first always push get push and again set your upstream and say in the origin is GitHub, you want this branch to be synced with you. Okay, this is what the last command guy I showed you in my last class also. It's an origin If this branch is not there, they will first create this branch. That's what they do. Then further they start tracking this branch. Okay. So now again, they are up to date, but you're up to date with the GitHub. And if you see in the GitHub also, this new branch has been pushed recently, and you can see the name over the after refresh also, you will see there's 2 branches come up, and this is the details you have. Okay. And what's actually idea? The idea is something like this. Okay, maybe somebody, yeah, you have one project in the GitHub. This is the how it works. And somebody download this project, maybe let's say with a clone, they download in the local laptop. Okay, and when developers start working on the laptop, how they do, they create a new branch with the name of dev1. Okay, so they create dev1 branch to add a new feature, or maybe some of the open source projects we have, somebody download the entire open source project rather than touching their project, because their project is there in the master branch. Okay, we create a new branch by, let's say, dev1 to add a new feature. After we added the new feature, okay, now we are not pretty sure. Okay, guys, this is very interesting use case. Now we are not pretty sure that what feature we added is perfectly or not. Should we add this feature on the master or not? Because this project is not created by us, it's an open source project created by somebody else. Okay, so what can we do? We will upload my dev1 branch to this project and ask them to create their one more branch with the same name dev1. So what a feature you added, it will update in the GitHub. So in their project, they already have the master branch, but now they have one more branch called dev1. You can see dev1 branch come up. And the guy who is maintaining this project in the GitHub, they will see and they check, the team will check what the code you added, DDD is working fine or not. All right, they will check the entire thing. And if they think what are things you added is perfectly fine, okay, perfectly fine, so they can take the decision. Okay, they can take the decision in the GitHub to merge this your feature into the main project in the master branch. Okay, how they merge? So even though if you go to the master also, they're showing you here, okay, that there's one branch come up, is one commit ahead. Do you want to merge? I can say yes. This is what I show you. So there's somebody come from dev1 branch. I want to merge my base branch called master branch, right? And I will pull means check the difference. So there's some new one commit they added extra. Okay, so do you want to merge? So yes, I want to merge. Even though guys, even the merging also, we can do squashing also. You know what is squashing? I show you today. Okay, so this thing also we can do. But let me go for merge. But squashing also we can do directly here. The concept of squashing I explained to you already. I want to do merge. And do you want to merge? Confirm? I say yes. Okay. And now this team has got your data and put in the master branch. And for them, this branch is not at all important for them. Okay, because they already merged, so they can delete this branch. That is a very common scenario. That was this option you always see, delete. So they will delete this branch there. Okay, and finally, for the put comments, they want to put the comments over here. Okay, and if you see and go back, now we have only one branch. Okay, but in this branch, let's go master, we have an up-to-date data, DDD. So technically, you know what I'm trying to say you, okay, this circle, right? You download this project, maybe open source in local system, you don't change directly here because you don't want in the management. You create your feature branch, changes here, you upload to this guy, to this team. Maybe they are your team only, okay, in your different branch. They look your data and they feel is good to go for merging. They merge here and they delete the branch there. Okay. Or maybe they might do some small changes here while merging, because normally when you merge, mostly you have merge conflict that will be discussed tomorrow. You might have some conflict. There might some changes here before the merge in the master branch. So as the developer one, you want to again further want to go in your more feature in this project. So we again download this code from the master branch. Okay, how? So in this case, you will go in your local system, go back to the master branch. Okay, and if you see the status is clean, but I don't know, I'll go and search first, fetch my data. Okay, fetch my data from my GitHub. Okay, because technically maybe they have some extra commits, so this fetch will fetch the information. Okay, the fetch the information that something has been changed there. Then we show you are one behind. If you're one behind, just go and get the pull and get the things. Okay, so now it's been pulled, and now this data has been updated in my local branch. Okay, so this data again come back to your local system. How? The updated one. Take from you only, but they might have to do some changes here, because normally when merging, there are a lot of conflicts come up. Something to change before we merge. This will talk. I will talk tomorrow, and then you will again download in the master branch so they can start working on it. But for working, this feature branch is not required because they already deleted. You also have to delete. So first you will get branch, delete your dev one. Okay, and again you still get the same branch, other branch name, and start working. Same circle is keep on going on. So this is the way normally we contribute on the open source. Some more thing we have to again do, or this is the way normally we start keep on contributing the data, again getting the data back, again work, again we provide. Okay, so it's a some kind of cycle. We have some more discussion to be do here after you guys come to know merge conflicts. Simple topic, nothing very technical. We can do much more thinking. But this is one good idea we have created. This is how things work. I think you also understand the meaning of fetch and pull, push, clone, and some kind of branching concepts more, right? So that's all guys for today.